big problems about studying physics is that when, well, you study physics, sometimes you get into the theory and the mathematics too much, and pretty much you can't really figure out how to really apply it to real life. And so application is very important, and this is the video for you. This is a study of kinetics, specifically projectile motion, and we will be using a very important scene from Lord of the Rings where we basically toss a dwarf.
Don't tell the elf. Not a word.
Projectile motion is basically when an object is following a parabolic or curved path. And the reason it does this usually in all of these examples is because gravity is a very, very rude thing. Before Newton discovered gravity, we were all having so much fun. Jokes aside. The thing that makes projectile motion slightly awkward than normal kinematics that you might have encountered is the fact that things happen at angles. And basically what we have to do now is decipher these angles into X and Y components, horizontal and vertical. The description of the scene of the Lord of the Rings is basically Aragorn tossing Gimli across. We don't tell the elf. And there's a massive gap that he has to get across, but also the gap or the layer where the orcs are is slightly lower level. So there's a few approximations we have to make. Our goal here is to calculate how far across Gimli got yeeted, but also how long he was in the air. The first thing we estimate is the speed that Gimli is at. And we did a couple of things on my live Twitch stream to calculate this. Some of the things included calculating frames per second. Others did estimation of distance traveled per second, but basically we came up with 4 meters per second. The angle at which he was yeeted looked roughly 45-degree angle, and this is a chef's kiss of an angle to choose because this is the ideal angle to throw something usually. In this example, Gimli is being tossed at 4 meters per second and at an angle of 45 degrees. There is, however, also the issue that the level where Gimli is at and where the orcs are, there's a bit of a gap. And looking at the video over and over again, and again, estimations and conversations via my Twitch chat, we confirmed and believe that it was roughly 1 Gimli. This is a standard unit of measurement, and you cannot argue against me on this. 1 Gimli is roughly 1.37 meters. And so we estimate that the difference in height is about 1.37 meters in the vertical axis. As Gimli is being thrown, he follows a parabolic path, i.e. a curved path of motion. Basically, because we ignore air resistance, we say that the horizontal path remains constant. Nothing is changing the horizontal component of his speed at any point in time. We physicists love ignoring air resistance. But the y direction, the vertical component, changes every millisecond. At every point in time that Gimli is in the air, gravity is acting against Gimli, and at some point, at the highest peak, he wouldn't even be moving in the y direction. And then we'll begin to accelerate downwards. The vertical velocity changes at every moment in time. Here are some of the classical equations from kinematics that you would usually use to solve these problems. However, again, the problem here is linear motion. At the moment, we're at an angle and we're not exactly at linear motion, but we will decipher this. We have to break down Gimli's projectile motion into its x and y components. So I hope you remember your trigonometry. If Gimli is being thrown at 4 meters per second at an angle of 45, we can depict the x and y component basically by using Pythagoras' theorem. Remembering your sine, cos, and tan rules, we can determine the speed of Gimli at the moment that he gets thrown in the x direction and the y direction. Remembering that opposite over hypotenuse is equal to sine 45, you can rearrange the equation to determine what the line of the opposite side is, i.e. his speed in the y direction. The answer is 2.83 meters per second in the y axis. We can do the exact same thing except using cosine rule, adjacent over hypotenuse is equal to cos 45, and determine as well that the answer is 2.83 meters per second. What is going on? Why is the answer the same? Is this a mistake? No, this is what 45-degree angle is all about. So if you ever see that 45-degree angle, know that your components are going to be the same in the x and y. This is great. We just determined at what speed Gimli is going up initially and at what speed he's going sideways initially as 2 separate components. The first part we're going to determine is how long was Gimli in the air? And we have 3 kinematic equations we talked about earlier. You could sit there and basically decipher, tick off what information you have and what information you're looking for. And using this method, you can determine that you need the s is equal to ut plus a half of at squared. The x naught cancels off because that's the initial position and the initial position is 0. What we're doing here is we're substituting all the y components. How long Gimli is in the air is only dependent on the y vector, all the up arrows and all the down arrows, and that's what we're substituting here in this equation. We determined that roughly the height difference was 1.37 meters, 1 Gimli, but remember it has to be a negative. And also remember that when substituting for gravity, you have to make it minus 9.81 meters per second squared, because gravity is acting against us. We then get ourselves into a quadratic equation and we use the minus b formula. We know what the a component, b component, and c component is. I simplified the mathematics here and subbed in all the values, but we get two possible answers because there's a plus or a minus part of the equation. Two answers result in 1.124 and the other one is minus 3.189. And I am ignoring the negative sign because, well, time doesn't move negatively, technically. That's another story for another time, why it can be negative. But in this case, we can only take a positive answer for time, and so we've determined that Gimli has been in the air for 1.124 seconds. Now that we know the time that Gimli has spent in the y-axis, how long he was going up and how long he was going down, that's also the amount of time that he spent going in the x direction. That kind of didn't change. If we know how long he was up in the air for, we know exactly that's how long he was going for when he was going in the x direction with no air resistance, and it didn't change in speed. And so using your simple speed equation, v is equal to distance divided by time. We know that his speed was 2.83 in the x direction. We know he was in the air for 1.2 seconds. Multiply those values together and we estimated that he got tossed at 3.18 meters. You can evaluate the video and determine that maybe we're slightly off on the meters. Feel like there could have been an extra meter there by eyeballing the image of the film. But overall, I thought the estimations were pretty accurate. I hope you found this video informative, educational, or at the very least, a bit of fun. The most extended credits go to Medjay, a dear friend of mine who animated this whole series. Fantastic artist and a fantastic human being. And thank you so much finally to my Twitch chat who participated live in solving this problem. Take care of yourself, stay safe, and stay curious.